In terms of what we're actually going to cover for homeworks and exams, we're pretty much done at this point. Okay, so what I'm going to talk about for the remainder of this class, you can think of as sort of just cultural enrichment, because there's no more homework to do, and the material in terms of what you're responsible for on the test, on the final exam, pretty much up through index of refraction, Snell's law, total internal reflection. You should expect a question or two on that on the exam. What I'm going to talk about now is another important application of these sorts of ideas, but we just don't have a lot of time to go into it in too much depth, so I'll just kind of hit the highlights. Let's say you have a prism, and unfortunately I don't have a prism here that's shaped quite the way I want it, so I'll just have to draw it out. A prism is just a piece of glass or some other high-index material that's shaped like a triangle, right? And if you shine a beam of light through a prism, well, actually two things will happen. One is you'll actually get what's called diffraction, meaning that the colors will separate, or white light will separate into its constituent colors, right? We're not going to focus on that too much. We're just going to focus on, let's say you have a monochromatic beam of light. We're not going to worry about the color separation. And we're just going to look at the refraction through this prism, okay? So let's say I have a beam of light traveling in this direction. And it hits this surface. And so I have, this is air out here, so this is low index, and we have glass, high index here. Well, it hits this surface, but we have to draw the normal to the surface, right? So there's the normal to that particular surface. So if it goes from air to glass, it's going to be bent toward or away from the normal. Toward the normal, okay? So it's not going to go straight through. I have to draw the new light ray kind of like that, okay? So this angle between here and here is smaller than that angle. And that light ray will continue through until it hits the next surface, and now we have a surface at a different angle, and that is the normal there. And so we have that angle between the normal and the incoming light ray. But now it's going from the glass into the air, so now it's going to be bent away from the normal, right? So I should draw this angle bigger. And it's a little bit hard to draw, but you can see that that angle, I'm trying to draw this angle being bigger than this one. It's bent away from that normal. And so it happily proceeds along in that direction, right? So we have a way to actually change the direction of the light beam as it goes through from one end to the other of this prism. What if I have another prism? Let's say I have another prism here. I'm going to draw it in the opposite orientation. And I have another light ray that happens to be parallel to this one coming in. And it hits this interface, and again it's going to be bent towards the normal. So I draw this angle smaller. And it hits this interface, and it's going from glass to air, so that again it's going to be bent away from the normal. And so we're going to have something that looks like that. And now I have two light rays. Initially they were parallel to each other, coming maybe from some distant source very far away, coming in parallel lines. And after they travel through these two prisms, they're bent toward each other and will actually converge and meet at some point. What if I just made? What is this called? It's a lens. It's probably the simplest lens you can think of. It's basically just two prisms or two angled pieces of high index material, angled in such a way so that on the top half, light rays are going to be bent downward, and the bottom half, parallel light rays will be bent upward, and they'll meet somewhere in the middle. Okay. So I could, instead of having this ugly shaped prism, I can do something like this. Have a piece of glass maybe shaped like this, where it basically does the same thing. If you look at a tangent line to this curve, it's bent in that above the center line here, it's bent, it's tangent in such a way that it's going to cause light rays to bend downward. Down here, it's angled the other direction, just like this prism, and parallel light rays will be bent upward. Okay, so this is called a and it's called a converging lens because it makes light rays, parallel light rays, converge to some point. What if I wanted to make a diverging lens out of these two prisms? What do I do? Yeah, just flip them, right? Make it, yeah, exactly. Make it look like an hourglass. So that if you had something like that, you have a light ray coming in, bent toward the normal inside the prism, bent away from this normal as it exits the prism, and that light ray goes off and diverges away from a parallel light ray down here, which is bent toward the normal, and then again bent away from the normal. And so this is a simple example if you wanted to do something maybe look like this, where it looks concave, at least on one side. Could look Actually, this is another example of a diverging lens could be something like this. It doesn't have to be concave on both sides, as long as it's thinner in the middle and thicker on the edges, whereas a converging lens is thicker in the middle and thinner on the edges. So this is a diverging lens. And we can show that. Okay, so we have parallel light rays, and if I place a converging lens there, right, we have it's thicker in the middle, thinner at the edges, and it's all the light rays that are coming in initially parallel to each other are being bent toward a point. And if I have a lens that looks maybe like this, that's not terribly dramatic, but I think you can kind of see how they're bent away from each other. Let's see if I can find a better one. What if we have something like this? This is probably not quite as good. Ooh, that's a mirror. Never mind. That's not a lens. That's a mirror. Unfortunately, we don't have time to go into mirrors. That's too bad, but that's a converging mirror. Do we have a better diverging lens? Maybe this one. Unfortunately, doesn't cover the whole span here, but a lot of weird stuff going on there, huh? Looks like we got some total internal reflection, and what if we do that? Well, it's mostly divergent. All right. But you get kind of the idea, okay? Let's go back to a converging lens. Parallel light beams come in and are converging to a point that's called what? The focal point. Yeah, this is the focal point. And so the definition of this thing called the focal point is if you have a converging lens so parallel light beams converge to the focal point. And the distance from focal point to the center of the lens is called the focal length.